In this Dr. T's Research Method Basics video, we're going to take a look more closely at how we might use a standard normal probability distribution. Now, at the end of the last video, when I was talking about the normal probability distribution, I gave you a little teaser about a standard normal, and I told you that with a standard normal probability distribution, essentially what we're doing is we're standardizing both the mean and the standard deviation. We set the mean to 0 and the standard deviation to 1. There are several reasons for this. One is that it makes it a lot easier for us to figure out where any particular observation that we are interested in falls under a standard normal curve. What does that mean? It means I can tell you how many observations fall below the one I'm most interested in. And with just a tiny little tweak, I can tell you how many fall above the one I'm interested in. All right, so let's try to put this into some kind of practice. Maybe it'll make some more sense. First, what I want you to recall is the idea of a z-score. Now, the z-score is particularly useful with a standard normal curve because z-scores correspond to the values on the horizontal axis of a standard normal curve. Okay. We won't very often start with a z-score, not in our data. We will probably have some x value that is meaningful in whatever work we're doing. But we need to take that meaningful x value and somehow get it from a normal standard distribution into a standard normal. And the way to do this is using a z-score. The equation for z is our x value that we're interested in minus the population mean divided by standard deviation. Okay, so let's say that the x value we're really interested in, for whatever reason, the x value that we're interested in is 3.86. All right. Well, let's try to figure out where this 3.86 falls under a standard normal curve. I'll say that a different way. What is the probability that any random score we grab in our data is going to fall below 3.86? All right, let's go ahead and turn this 3.86 into a z-score. We'll just use the population mean and standard deviation that I have here on the right And we'll plug in the values that we know. So z is equal to 3.86 divided by, well, 3.86 minus 3.5 divided by the standard deviation, 1.15. All right. Go ahead and pause me for just a minute, plug that into your calculator. Hopefully you and I came up with the same z-score. I came up with a 0.31. Well, what does that mean? How am I going to get that under the standard normal curve? Still making no sense to me. Well, it's because we're missing a piece. What we need is called a z-table. Here is a z-table. Let me tell you how to use it. The z-score that we just figured out was equal to 0.31. All right, here is our z column. Essentially, we're going to use this table to find 0.31 along the z numbers here and here. All right, so I'm going to start with this vertical z column, and then I'm going to look at the z rows. So z, I'm looking for 0.3. Well, here it is, 0.3. Now I'm going to follow this row across until adding what's in this column to something in one of these rows right about here equals 0.31. So 0.3 plus 0.01 equals 0.31. All right, cool. Where does it fit? Right here. 0.6217. Okay. So 0.6217. That's where our z is. Now I've gone ahead and I've just noted what we got from the z table here. So if we have an x in these data, whatever data we're looking at 3.86, that's the point we're most interested in. And we want to know where it falls under a standard normal curve. This 0.6217 is telling us how many standard deviations away from the mean this score falls. All right. Well, under a standard normal curve, a standard deviation is equal to 1. Our z-table tells us that this x value is about 0.6217 standard deviations away from the mean. So let's see, about here maybe? About there. And I'm going to label this with our x value. And what we know now is that there's a pretty good probability that we could randomly take a look at our data and find an x value of 3.86 or less in the data that we're looking at. 3.86, well, it's definitely falling within the largest part of the curve. It's not a super uncommon value. We might find an uncommon value way out here or way over here on the left. No, it's a pretty common value. Now there's another way to use a z-score in a z-table, and it is this. You may come across a time or an instance where you are asked to find the area to the left of z. All right, well, in a problem like that, you'll usually be given the z-score right off the bat. So if the area that we're looking for is to the left of z, and let's just say the z that this problem gives us is equal to 1.23. Then we need to take a look at our z-table. This time we're looking for z is equal to 1.23. So we'll start first here, and we're looking for 1.0. There it is. And then I've got to figure out the 2,3 part, don't I? So 1.0 oh, we could actually come all the way down here to 1.2. Duh. We'll start with this 1.2. Now we need to add whatever's going to make it 1.23. Well, here's the 0.03. Here we go. That's what I'm interested in. 0.8907. So taking a look at our standard normal curve, 1.23, which, I don't know, right here. Well, we know that 0.8907 our observations fall to the left of 1.23. That's great. But so, well, let me show you something. What I can do is multiply 0.8907 times 100, and I can say roughly 89% of the observations that I'm looking for fall below 1.23. Interesting. So how many are above? Well, if under a curve always equals 100% of our observations, right? 1. And I know that the 1.23, I have 0.8907 below, and everything under the curve is equal to 1. I'm going to go ahead and subtract 0.8907 from 1. I get 0.1093, or 10.93% of the observations in my data fall above 1.23. Pretty cool.